So what exactly is VMware fault tolerance and how does it work? Well, fault tolerance is the highest level of availability available for your vSphere virtual machines. You'll want to save it for your most critical applications that can simply never be down. At a high level, if we look at our vSphere 3-host cluster that we've been working with, and let's say that we have a single virtual machine running in that cluster, which just so happens to be running our company's most critical application. We're going to enable VMware fault tolerance on that virtual machine, making it the primary virtual machine in the fault tolerance pair. We'll also have a secondary virtual machine, which is known as the shadow virtual machine or the secondary virtual machine running on a second host in the cluster. VMware fault tolerance will perform real-time synchronization of the memory between the primary and secondary virtual machine. So everything that happens on the primary also happens on the secondary VM. In the event that the primary host fails, and of course the primary virtual machine fails along with it, the secondary virtual machine will take over as the new primary VM. Now, there are a number of requirements that go along with VMware fault tolerance, as you might imagine. The first one being around CPU requirements. For example, Intel Sandy Bridge CPUs or later are required. Avoton is not supported. These are families of Intel CPUs. And then on the AMD line, AMD Bulldozer family CPUs or later are required to use VMware fault tolerance. You'll also need a 10 gigabit low latency network between the hosts running the virtual machines for the real-time synchronization of the memory between the hosts. And then a dedicated interface is recommended for VMware fault tolerance. You'll also need to meet the fault tolerance licensing requirements. For example, VMware vSphere standard level is required, and that will allow virtual machines with up to 2 vCPUs. On the other hand, if you have virtual machines that have more than 2 vCPUs and you want those protected with VMware fault tolerance, you'll need vSphere Enterprise Plus, which will allow virtual machines with up to 8 vCPUs to be protected with VMware fault tolerance. There are also a number of features that are not supported with fault tolerance that you should be aware of. For example, virtual machines protected with fault tolerance cannot use snapshots. You cannot storage vMotion a virtual machine while it's protected with fault tolerance. You can't use linked clones. They can't be running on data stores that use virtual volumes. You also can't use storage-based policy management on virtual machines protected with fault tolerance. You can't use I/O filters, disk encryption, or the TPM security module, or the Microsoft virtualization-based security features on virtual machines protected by fault tolerance. With these requirements and limitations in mind, let's now move forward with the configuration of fault tolerance, starting off with the network configuration. To configure the networking for VMware fault tolerance, VMware highly recommends multiple gigabit network cards, one for fault tolerance, another for VMware vMotion. Of course, 10 gigabit networking is also recommended. However, I can tell you for lab environments, these are not requirements. You can take a single gigabit Ethernet card and enable it for both fault tolerance and vMotion. Let's go over to the Wired Brain Coffee Company virtual infrastructure, and I'll show you how. If we take a look at the 3 different hosts that make up our production cluster here in the Wired Brain Coffee Company, and select the configuration tab, then go into VM kernel adapters. Here you can see on this host, we have 3 VM kernel adapters. If we select the first adapter, VM kernel 0, you can see the enabled services are currently vMotion and management. And if we select the second adapter, we have no services. And our third adapter, VMK2, only has vSAN enabled. Since we already have vMotion enabled on VMK0, we're going to enable fault tolerance on VMK1. To do this, we'll edit the properties for the VM kernel adapter and simply check the box here that says fault tolerance logging. I'll click OK on that. And this gives us a warning that this VM kernel adapter is bound as well to an iSCSI initiator. And by enabling the fault tolerance service, we'll actually have fault tolerance and iSCSI utilizing the same physical adapter. So what we're going to do is to actually move the iSCSI binding to a different adapter. We'll go ahead and say OK for now. And then let's go into our storage adapters and into the iSCSI initiator. And let's actually change the network port binding here off of VM kernel 1 and simply leave it only on VM kernel 2. I'll go ahead and remove this binding. But of course, this is also removing our multi-path configuration to the iSCSI array. So everything has consequences. Just keep this in mind. We're going to go ahead and rescan the adapter, and everything is as good as new here. So at this point, we made our configuration change on node 1. If we look at our VM kernel adapter, VMK1, you can see that now fault tolerance logging is enabled. So let's go ahead and do the same thing on the other two hosts that make up this cluster. I'm going to add fault tolerance logging here and go to the storage adapter and remove iSCSI port binding. Rescan. And then finally on our third adapter, in fact, let's remove iSCSI port binding first, since we know that warning is going to come up. And then go to our VM kernel adapters and add fault tolerance logging. At this point, we've successfully configured the networking that's required for VMware fault tolerance. All three hosts in our cluster have fault tolerance logging enabled. Before we enable fault tolerance, let's talk about some of the different scenarios where fault tolerance would best apply. While fault tolerance is the ultimate availability solution for vSphere, it's not something you want to go in and just enable on every single virtual machine that you have, for a variety of different reasons. One being, for every virtual machine that you enable fault tolerance on, a shadow virtual machine that's going to consume the exact same amount of resources will be created on another host in the vSphere infrastructure. So you'll essentially double the amount of resources consumed. Because of that, you'll want to pick and choose which virtual machines to enable this on, and not every virtual machine is going to be the best fit. For example, let's say that you have a print server virtual machine with 2 vCPUs. While vSphere Standard would support a maximum of 2 vCPUs enabled on a virtual machine with fault tolerance, you have to question yourself, is a print server a really critical virtual machine? I think most administrators would say no, but of course I suppose it depends on the organization, just how critical printing is. On the other hand, what if you have a critical database server virtual machine with 2 vCPUs? Again, vSphere Standard would support this, so you need to make sure that you have at least vSphere Standard or above. And by it being labeled critical, you would think that this might be a virtual machine that you should consider for VMware fault tolerance. And then perhaps you have a tier 1 application server, a virtual machine that has 6 vCPUs. Well, if you have vSphere Standard, it's not going to support up to 6 vCPUs, so you'll need vSphere Enterprise Plus, which would support up to 8 vCPUs on a virtual machine enabled for fault tolerance. On the other hand, bonus question, let's say that you had a tier 1 application server virtual machine that had 12 vCPUs. Even with vSphere Enterprise Plus, you're not going to be able to enable vSphere fault tolerance on that virtual machine. With these scenarios in mind, it's now time to get started and enable fault tolerance. I think you'll be pleasantly surprised just how easy it is to enable VMware fault tolerance on a virtual machine in the vSphere infrastructure. If we go over to the vSphere client, let's say that we have a virtual machine at the Wired Brain Coffee Company that we want to enable fault tolerance on. Maybe it's a critical database server or application server. Enabling vSphere fault tolerance is super easy to do. Simply right-click on the virtual machine and go up to Fault Tolerance and then over to Turn on Fault Tolerance. And upon selecting this, you'll see the results of the fault tolerance compatibility issues, which you may or may not have. In our case, we have 2 errors. First one being that the USB controller is not supported, and neither is the NVMe controller on this virtual machine. And this is a good time to point out that fault tolerance has a number of limitations or incompatibilities. Besides not supporting USB controllers or NVMe storage devices, it also doesn't support physical raw disk mappings, connected CD or floppy virtual devices, sound devices, NIC pass-through, hot pluggable devices, serial or parallel ports, video devices that have 3D enabled, or virtual machine disks that are larger than 2 terabytes. In our case, we're not going to be able to enable fault tolerance on this virtual machine until we resolve these faults. So let's try another virtual machine for the purposes of this demonstration. If we right-click on the Legacy WinApp virtual machine and go into fault tolerance, you can see here we can turn on fault tolerance, and we get one issue, which in this case is simply a warning that the virtual NIC associated with this host has insufficient bandwidth for vSphere fault tolerance logging. And I'll tell you that's because it's a 1 gigabit Ethernet connection, although it is a dedicated adapter. But vSphere gives us this warning because that interface is not a 10 gigabit Ethernet adapter. So if you're running fault tolerance on production virtual machines in an enterprise environment, I encourage you to ensure that you're using 10 gig Ethernet adapters. However, in our relatively small lab environment here at the Wired Brain Coffee Company, we shouldn't have any issue enabling fault tolerance. I'll say yes, and this brings up the fault tolerance wizard, which first asks us to select the data store to place the secondary virtual machine disk and configuration files. Keep in mind that this virtual machine that's being created as the secondary or shadow VM will be a full virtual machine with its own disk files and its own CPU and memory consumption. And you may want to select a different data store than what the primary virtual machine is using. In our case, let's go ahead and select an iSCSI SAN, click Next, and then we want to select the host to run the secondary virtual machine. I'll go ahead and select Node 1. And again, we get the warning message that this host has insufficient bandwidth. That's, again, back to the 1 gigabit Ethernet adapter. You just want to make sure that you use 10 gig in production environments. I'll click Next and Finish. And now we should see a secondary virtual machine being created. You can see that the primary virtual machine is now labeled as the primary VM. If we check the status of our recent tasks, we can see that the secondary virtual machine is being created. Let's give this a moment to complete. As you can see, we've successfully enabled or turned on VMware fault tolerance. You can see that by the task having completed successfully down in recent tasks. You can also tell by the color of the icon for this virtual machine, it's changed as compared to other virtual machines. And then on the virtual machine summary tab, if you scroll down, you'll see a new section called fault tolerance, which says that this virtual machine is indeed protected and the secondary virtual machine is running on node 1. You can see that the log bandwidth is currently consuming 56,368 kilobytes per second. So that's why those network adapters are so critical, because they'll be used heavily to synchronize the changes to the virtual machine between the primary and the secondary. So the secondary is running on node 1, and the primary, as you can see, is running on node 2. Our next step is to test fault tolerance, and let's prove that fault tolerance really works. All right, it's now time to test our fault tolerance configuration. This should be a lot of fun. What we're going to do is to actually pull the power plug on the host that's running the primary virtual machine, and we're going to see how our application, which we're going to be simulating with a continuous ping, is going to behave. This is always a lot of fun and a little scary. Thankfully, this isn't our production application, but let's pretend that it is for the Wired Brain Coffee Company. So we'll cross our fingers and hopefully everything goes well. Again, we have our primary virtual machine that's protected, as you can see down here, by VMware fault tolerance. If we go to that virtual machine, let's go ahead and start a continuous ping. Going to the default gateway, you can see we're getting great response time, although not as good as before when we actually performed a vMotion, because there's a lot of workload and stress being put on the virtual infrastructure in this virtual machine. by replicating every single thing that's happening in the memory of this VM to the secondary virtual machine. This takes a lot of resources, and I can actually see the results of that in the increased ping times. Still, our ping times are very good. So now to actually pull the power plug on the host that this virtual machine is on, by the way, if we go to node 2 and virtual machines, here is the virtual machine. So it's running on node 2. And I happen to know that node 2 can be reset if we go to the KVM interface, which is simply easier for me to do. Instead of going into the lab and pulling the power plug, I can reset this host, which is going to simulate a power blip by clicking the reset button right here. So let's go back to the vSphere infrastructure and let's see what's going to happen to this virtual machine. We can see that our pings have momentarily paused. And if we go to the vSphere client, let's see what's going to happen with this virtual machine. I already see a message on node 2 that node 2 is having an HA issue, a possible power failure or host failure has occurred. And if we go to our virtual machine that's being protected by fault tolerance, you can see that the fault tolerance state has changed. And if we go to that virtual machine console and push refresh, look at that. Our ping to the default gateway was continuing to run. I did a Control-C to break out of it, and you can see we experienced 0 packet loss, 155 packets sent, 155 packets received. If we scroll up, let's see if we could find the exact moment that that host failed and fault tolerance took over. If we scroll on up, it looks like most of the ping times were between roughly 4 to 15 milliseconds. And at the point that that host failed, interestingly enough, I would say the ping responses actually improved. So when the host failed, not only did we have 0 packet loss and no downtime for the application, because we weren't synchronizing everything that was happening from the primary to the secondary, and the secondary was able to simply take over, we had no application downtime and even a slight performance improvement. If we go back to the vSphere client, we can see that this virtual machine had a fault tolerance state change. Host 2 is not responding. And if we go to host 1 and look at the virtual machines running here, now this virtual machine is running its primary instance on node 1. If you remember earlier, the secondary instance was running on node 1. So this is how powerful vSphere fault tolerance can be, 100% uptime for your applications, even when your host has a catastrophic failure, a power outage, a system crash. All of these would normally bring down your application. And even with vSphere high availability, your operating systems and applications would have to be rebooted. This might take a few minutes, and you would lose whatever data was running in memory. But that's not the case with vSphere fault tolerance, and you saw it in action right here.